All right, welcome to the third lecture for AD 400. Today we're going to talk about agility and what processes go with agility. Really, this focus on agile processes is because this is the most effective software engineering solution that has been found to date. So we definitely want to spend more time with this. All right, so what is agility? Here's the big question. What is it? So we're not talking about physical agility, as in being able to like jump around or do gymnastics, but we are talking about something a little more that has something to do with the flexibility that comes with agility. So here we're going to be effective and quick to respond to change. All right, so we want to be flexible. We want all our stakeholders to be in regular communication. We want to make sure the customer is on the team, involved, making recommendations, saying no to certain things, saying yes to other things. Customer is an integral part of the team. We want to make sure that the team has control of the work that's being performed, so it doesn't get carried away. We're going to be doing smaller increments called sprints, which gives us the ability to focus on very particular features. And then finally, we're going to have a rapid incremental delivery of software. All right, so if we take a look here, we can see an XY axis where the X-axis is the development schedule progress, and here we have the development cost. So if you take a look at this black line, the conventional cost of change for our software process, such as with waterfall, you can see how high this goes very quickly. As much as more change comes to be a part of this, the cost gets higher. Ideally, we want with our agile processes there to be very little cost or for it to level off. In reality, it's probably going to be more like this, where it doesn't go as high as our conventional software process, but it does still raise, and especially starts to raise even more as time goes on. All right. So what is an agile process? It's driven by what the customer wants, the descriptions that they're given. So there will be scenarios developed, use cases that will be developed, and these will be used as kind of like a roadmap or a platform for us to understand exactly what needs to be created. Customer feedback is frequent and acted on immediately. Plans are often short-lived, and there's an awareness of that, right? So there's no like unwieldy hanging on to particular plans. The ability to pivot, right, and to be amenable to change. Software is being developed iteratively, of course. We want to have different versions. We want to make sure that we can see what the problems were with a different version and then upgrade and make it better. There's a heavy emphasis on construction activities. So here we're talking about coding and testing, right? We want to be constantly in some sort of form of production of our code. We're developing prototypes, executable prototypes, and similar to the prototype iterative process model, and we're easily able to adapt as changes occur. Okay, let's talk about the agility principles. So the first is rapid delivery leads to customer satisfaction. So Agile prioritizes customer satisfaction by focusing delivering value through software. The aim is to provide tangible benefits to the customer by rapidly delivering working software that meets their needs, so those prototypes. By involving the customer through the development process, it ensures that the delivered software aligns to their expectations and provides value. So there's not this steep cliff, right, of where the customer was last contacted and understood where the software was and then what's delivered to them ultimately, right? They're aware, they've been through the whole process. We embrace change with Agile. We know that requirements are going to change over the course of a project. Instead of resisting it, we embrace it as an opportunity to improve our software. We have a lot of delivery of increments, so they're frequent. We deliver these to our stakeholders rather than waiting for months. We're constantly taking shorter cycles they're usually measured in weeks, and we're delivering some sort of prototype to our stakeholders. That allows us to give them valuable feedback from early on and ensure the software aligns with their expectations, enables timely adjustments and improvements. What this really strikes me as, or always has, is this idea of avoiding assumption, right? So we have this customer and they want a particular set of things, right, like requirements. And so they give us what they want, right? They give us the idea of what they want and they lay it out. And in a typical fashion, they're probably very general about it and pretty high level. And so we take that and we try to figure out, okay, how can I turn this into, some sort of software product? And but the reality is that things change, requirements change, the customer changes their mind, or they don't realize certain things, such as limitations they wouldn't see that we would know. So by having them involved on the regular and delivering them increments, we're able to avoid assuming what they want and actually get their feedback on what they want, and this avoids problems later. Agile is all about collaborative face-to-face communication. So you're going to learn with Scrum processes, we have daily stand-up meetings. We want lots of communication that's effective. Face-to-face interactions, whether written, face-to-face interactions rather than written or remote communication. Direct collaboration and open communication fosters better understanding of requirements. It addresses issues promptly, builds strong relationships. Of course, we're going to have a bit of a situation in our course where, unless you all want to really go the extra mile, you're going to be having a sprint planning meeting every week, and I assume you're all going to do it on Zoom rather than face-to-face. If not exactly ideal for an Agile process, but acceptable considering the situation. We'll talk more about that later. Motivated individuals, right? Motivated individuals that come from working on these projects. The motivation of these individuals drives productivity and creativity, fosters an environment of support. We're focusing on technical excellence and simplicity. Good design practices and simplicity is really a big part of this. We want well-designed, maintainable, and efficient code, lack of coupling, and lots of cohesion. Focus on eliminating unnecessary complexity, avoid over-engineering, and delivering software that meets quality standards. So lots of testing, lots of quality assurance. Want to eliminate any unnecessary work. So we want to focus on delivering the most valuable features and functionalities that match with the customer's needs. Working software that meets the customer's needs. Strong emphasis on delivering working software where the functional requirements are met. We want that customer to be happy and also recognizing that their product is being developed and giving us feedback. We need a sustainable pace. Recognizing the importance of maintaining a sustainable pace for the team is essential. It emphasizes the need to balance productivity with the well-being and effectiveness of their team members. So we don't want burnout. We don't want overwork, right? We're not trying to. This is a lot of issues that at least I hear in the game industry is where they burn out their software developers by having such strict deadlines, and we need work-life balance because that produces higher quality results. We want our teams to be self-organized, right? So we want them to be able to be trusted to make decisions and manage their own work, good time management skills. We want to empower them to determine the best approaches, create well-structured architectures, design solutions, really it's like, moving beyond this idea of like having a team where there are people who are not engaging, right, or are not interested, right? A true agile development team, everybody is on board, passionate, motivated, and able to organize what they need to do. Continuous improvement, definitely want a culture of continuous improvement, looking at the work, improving on it, finding ways to make it better, analyzing the performance, finding ways to make the team better, being open and transparent about communication so that can improve as well. Definitely important. And finally, our primary goal is customer satisfaction, right? By delivering working software that meets the customer's needs, we find that customer satisfaction, and agile teams can provide this. This principle reinforces the importance of understanding and fulfilling customer requirements and ensures the team remain customer-centric in their decision-making and prioritization. Okay. So here's our Scrum framework. So what is Scrum? Scrum is just a form of agile development, and it comes from a term in soccer where people, I'm not really sure, I don't really have a lot of background with it, but I think that they have this quick meeting or they scrum together and they're figuring out what they do next. And that's kind of the model that we're looking at here with Scrum. So here you can see that we have something called a product backlog, and I'm going to go a lot more into Scrum in class in our video there. So this is just a brief overview, but we have a product backlog which is going to prioritize product features desired by the customer. This is basically just a list of tasks that need to be done. And then we have a sprint backlog, which is the backlog that's going to be used for that particular sprint. So the backlog items are expanded by the team, and over a series of 30 days, we have 15-minute daily meetings every 24 hours, and every 30 days is another sprint. So you have a sprint, it goes for several weeks to 30 days. Every day you have a 15-minute daily stand-up meeting where everybody's just engaged and interactive, and then done, and you leave. Obviously, I'm not going to require you to do stand-up daily meetings. That's a little bit excessive, but it's definitely good to know that, to be in the spirit of that model. And then new functionality is demonstrated at the end of our sprint. So some of the details around Scrum: we have backlog refinement meetings where developers collaborate with stakeholders to create and refine the product backlog. They discuss and prioritize user stories, refine requirements, estimate effort, break down larger tasks into smaller actionable items. We have a sprint planning meeting, which is a collaborative session where the product backlog is partitioned into sprints, which are time-boxed iterations. So the team, including the product owner and developers, determines the scope of the work for the upcoming sprint. They select user stories from the product backlog, define acceptance criteria, estimate effort, and create the sprint backlog. The goal is to establish a clear plan for the next sprint and define the work that will be accomplished. This is the meeting that you will be expected to have every week. You will be given a template on Jira on what to fill out about it, and more information about that is forthcoming. I've talked about the daily Scrum meeting. It's a stand-up meeting, brief and time-boxed, where the members synchronize their activities and give an update on their challenges as well as any sort of progress that they made. There's a sprint review, which is held at the end of a sprint to showcase the work to our stakeholders. So the team presents the deliverables, such as the prototype or working software, to our stakeholders for evaluation and feedback. Stakeholders have an opportunity to provide input, ask questions, and provide approval or rejection of work during the sprint. So there's going to be some of these, but they're not going to follow the exact model of after every sprint in our class project. And finally, there's a sprint retrospective where the team considers everything that was done during the sprint, discuss what went well, discuss what could be improved, and any lessons that are learned, address any bottlenecks or challenges faced during the sprint, and brainstorm ways to make things better. Some of the pros of Scrum is that the product owner sets the priorities, because they are the product owner is going to be the one that's most active in communicating with the customer. The team owns the decision making, so there's a lot of autonomy around that. Documentation is lightweight. and it supports frequent updating. The cons are it's difficult to control the cost of changes, may not be suitable for large teams, and requires expert team members. So we talked about this before about how there's certain models that really are going to require more expert team members because they can be rather complicated. All right, so this framework is called the Extreme Programming Framework. And so you can see here there's a series of different stages: planning, design, coding, and testing. So planning in extreme programming is going to involve listening to customer requirements and creating user stories that describe the desired features and functionality. Each user story gets assigned a priority based on its business value. The development team then assesses the cost of each story in the development weeks. Stories can be added at any time. Customers and developers collaborate to group stories into the next release, and once a commitment's made, the team orders the stories based on 3 approaches. 1, immediate implementation of all stories. 2, prioritizing high-value stories, or prioritizing the riskiest stories. So they either choose to take on all stories, the high-value stories, or the riskiest stories. So the design, XP design follows the keep it simple principle, discourages adding additional functionality based on assumptions. So one of the things we're going to look at are CRC cards, and they can be used for object-oriented thinking, organizing relevant classes. Prototypes are created for difficult design problems, and design occurs continuously throughout refactoring. Construction activity guides design improvements. So there's this model of here we have this coding that's happening in construction, and the refactoring is happening, and it's based on the design that's changing and growing and being altered. Pair programming is a big part of this. It's recommended because it allows 2 people to work together, solve in real time, and ensure code quality through continuous review. Basically, pair programming means one person's writing the code, the other person's testing or observing and ensuring quality. Testing in our extreme programming is going to involve creating automated unit tests using a framework for easy and repeatable execution. This promotes the implementation of a regression testing strategy when code is modified. XP acceptance tests specified by the customer focus on the visible system features derived by the implemented user stories. So the focus is on the customer being able to see the functional requirements are being met, right? They allow for the customer to review and are derived from user stories within a software release. And one of the things to keep in mind, especially here in involving the customer so much in the testing process, you're not going to always have a customer who's willing to engage at the level that some of these processes expect. And when that happens, there's going to be some customers just want to be like, here's what I want you to make, don't bother me until it's done, right? And that's completely understandable. I mean, they've got busy schedules and lives as well. But I think it's important that if a software development team is going to be using one of these models, there's transparent communication with the customer around expectations. It can be very difficult to really derive the value of the customer being so involved in some of these frameworks if they're not willing to be involved. So. All right, some of the details around extreme programming. We have an XP planning, which begins with user stories, short and multiple descriptions of a feature or functionality from the perspective of the end user. These user stories capture the requirements and provide a basis for planning and estimating. The dev team collaborates with stakeholders to understand and prioritize the user stories. There's a lot of estimates that are made around user stories to determine the effort required for implementation, and sometimes that can lead to planning fallacies around the idea of underestimating the amount of time and work it's going to take. But as long as these increments are shorter, it's usually the planning fallacy is not really that strong because the amount of features being implemented are not as much. Usually XP teams are using computer-based tools to track and manage user stories, project velocity, which is how much is getting done, a metric that's being looked at, and progress. This allows for more transparency and effective planning. So our XP design process follows the KSS, keep it simple, model, emphasizes on creating simple and elegant solutions, and often uses the CRC cards, which we'll learn about in next week, I think. These are physical cards used during design discussions and are a visual aid in refining the software's design. It also promotes prototypes to explore different solutions and validate design decisions before committing to a specific implementation. Frequent refactoring is a core practice in XP because it allows the code to be constantly improved while maintaining simplicity and flexibility. The coding in XP is actually done with constructing unit tests before actually writing the code. So this is known as test-driven development. So the developers write automated unit tests to define the desired user behavior of the code before they start implementing it. And the tests are expected to fail initially as the code isn't yet written. Right. Then the developers write the code, and pass the test, thus ensuring the code behaves as expected. So it's this idea, test-driven development, of here we're going to create this model of a test, right? And the only code that we're going to allow is one where this test pass. So we're kind of creating a framework or a series of gateways before we even start writing our code, because then we know exactly what we need to include in the code to ensure that the tests pass. Encourages pair programming. I talked about this. And then testing is a strong emphasis on testing. Unit tests are executed daily as developers continuously write and improve code. They offer fast feedback and catch defects early. Some automated acceptance tests are defined by the customer to validate that the software meets the desired functionality and requirements. Some of the pros of XP, where customers involved, again, in a big way. We have rational plans and schedules. Things are a lot faster, but they're also being produced faster and they're smaller. It requires the developer to be very committed to the project, so everybody's really engaged, and we don't have as much reduced product. It's a reduced likelihood the product will be rejected because we're delivering in such small increments that we can find out what the problem is and fix it. Again, a temptation to ship a prototype. We saw that previously. Requires frequent meetings about increasing costs. That can be an issue as the complexity increases. It does allow for excessive changes, so we can find that we're spending a lot of time on changes, and it requires a highly skilled team yet again. All right. So Kanban, or Kanban, however you want to pronounce it, is going to give us this framework that basically uses this type of project board where we have a backlog of items, and then we select items from our backlog, and then we perform analysis on them on whether they're being doing category or they are done, and then development of doing or done, and then we test, and then we put them into done. We also have an expedite lane. You can see here on the bottom where we will put any tasks that absolutely are higher priority. These are all using a Kanban board, which is a visual tool to track and visualize the workflow. I just showed you what that looks like. Our tasks or our user stories are like sticky notes that move across the board as we progress through the workflow. This helps give a strong understanding of the work in progress and promotes transparency and collaboration. We want to limit the amount of work in progress. So Agile teams recognize the importance of limiting the amount of work in progress at any given time. So by setting WIP limits, ensures that we don't take on too much work simultaneously, which can lead to bottlenecks, delays, and reduced focus. Encourages team to finish existing tasks before starting new ones, although there is space and room for simultaneous development. Managing workflow to reduce waste. We want to make sure we maximize our value delivery by reducing the waste of our time. By analyzing the current value flow, teams identify areas of improvement, eliminate bottlenecks, and streamline the process. Keeping an eye on all the processes, watching when they're slowing down, understanding what's happening, and acting on it is a big part of that. Making process policies explicit and defining done. This is huge, right? So what does done mean, right? Whether it's an iteration or a product or whatever, understanding what the done state means and clearly identifying it is extremely important. Otherwise, there could be, this process that just keeps going and everybody's like, is it done? Are we done with this? Did it meet the requirements we need? So identifying what done is very important. Having the policies be explicit is also very important at each stage in the work. We want to focus on continuous improvement. We've talked about this before, but in Agile development, we have feedback loops that gather insight and learn from our experiences. They allow us to identify areas of change and guide us to making incremental changes for processes, practices, and ways of working. By doing continuous improvement, we ensure the team adapts, grows, and delivers increasing value over time. And finally, collaborative process changes and stakeholder environment. We have collaborative decision making here when the process changes. We want all relevant stakeholders involved, all the team members, customers, in discussions and decision making processes. All these diverse perspectives are going to give us a well-informed decision to understand what needs to be changed in order to get us to the end without project rejection. Some of the pros are we have a lower budget here, lower time requirements, allows early product delivery, process policies written down, and continuous process improvement as some of the things we talked about. Unfortunately, some of the team collaboration skills will determine success, so if you have anybody who's not collaborating properly or effectively, then that is going to really slow the process down. Poor business analysis can doom the project, so like I said, you have to continuously be watching the project and analyzing how it's going and then modifying based on that. Flexibility can cause the developers to lose focus, and developers are reluctant to use measurements sometimes. This is true. You'll find there's a lot of developers out there that are not interested in quantitative measurements because basically they just take time and they just want to produce a product that actually fulfills a requirement. Once they see it's done, then they're done, right? And really, a lot of the quantitative measures should more so fall on the software engineer rather than the developer, as well as the project manager. All right, DevOps. So DevOps is going to combine development and operations and apply agile and lean development principles across entire software development supply chain. Okay, so here's a little story for you. When I was in industry, I was on the data science team, but also on the development team. And we had an operations team and we had a DevOps team. And so the DevOps team really works as an intermediary, like a middleware software almost, between development and operations. Because what operations was handling is ensuring the code goes to production, that's secure, monitoring it, deploying it, all of those things. If we have this team who has an awareness of all the development processes as well as all of the operation processes, we can create this symbiosis that allows us to kind of go back and forth in between them. And this actually makes things faster. There's a lot of automation in DevOps, at least the one that I witnessed when I was in industry. And some of the principles behind DevOps are we want continuous development. Here we're delivering software through multiple sprints, iterating, improving it, but always continuous. Continuous is the big word for DevOps. Continuous testing. So we're going to use automated testing tools to conduct tests on software before we integrate. They're going to enable the team to run a comprehensive suite of tests, including unit tests, integration tests, regression tests. We'll learn all about tests next quarter. But these automated tests are extremely important. They allow us to get rapid feedback on the quality of the code and identify any issues early in the development cycle. Continuous integration. So this involves integrating new code pieces with existing code in an ongoing iterative manner. It's really important that there is version control happening here because, integrating new code into existing code can be detrimental unless there's rollbacks. As developers complete their work on new functionality, they integrate it into the existing code base, ensuring the software remains in a functional and deployable state at all times. You don't want to enter the code into your code base and then suddenly everything breaks because there's a dependency you didn't count on. Continuous integration practices also involve version control systems, automated build tools, and continuous integration servers to streamline the process and detect any integration issues early on. Continuous deployment is going to be where we are deploying integrated code to the production environment on an ongoing basis. As each piece of code is integrated and passes the necessary tests, it can be deployed directly into the live production environment without delay. So there's not this whole idea of okay, we're going to build up all these different things and then we're going to have a release and push it, right? We're actually putting things into the live production environment on the regular as they're tested and ready to go. This allows for rapid and frequent releases of new features and bug fixes, ensuring the software is continuously updated and available to end users. And finally, we have continuous monitoring, which is extremely important. This allows operations staff and members to proactively monitor the software to ensure its stability, availability, and optimal performance. It involves using monitoring tools and techniques to collect and analyze data on system health, performance metrics, and user behavior. A lot of our non-functional requirements come into play here, which we'll learn about that, I think, next week. Continuous monitoring helps the team identify and address any issues promptly and ensures a smooth user experience and supporting ongoing improvements to the software. So some of the pros of our DevOps model is reduced time to code deployment. It's continuously being deployed. The team has developers and an operations staff, and they work together. The team has end-to-end product ownership and proactive monitoring of a deployed product. So they're constantly monitoring that product to see if it needs any sort of adjustments or modifications or improvements. Unfortunately, there's pressure to work on both old and new code, right? So there's a lot of different code to be working on, different versions to be working on, and understanding the code to the nth degree to understand how it is integrated. There's a heavy reliance on our automated tools. Otherwise, if we're testing without our automation tools, really it slows down the process of this DevOps model. Deployment may affect the production environment, so this is a big deal. If somehow something slips through the cracks of testing and gets deployed into our production environment and it breaks something, well, then we have to fix it real fast. Otherwise, the customer is not going to be happy, right? So there's that risk. So there's a little bit of a less strict assurance around what's being deployed being without fault. And this definitely requires an expert development team. These people are not only well-versed in development, but they're also well-versed in operations and how deployment and integration works, as well as probably a lot of security measures. So it's really a kind of a full stack situation. Okay, so that is the end of this particular video. Thank you for joining me, and I will see you in